it says without a calculator. Now, it is a calculator-based test, so I'll show you two ways. Without a calculator, you have to rewrite it in exponential form. 7 to the question mark equals 343. And then it's just guesswork, and you can see that question mark will be 3. With a calculator, just use the change of base. So pretend it's base 10, okay, and then divide by the log of the actual base, and you should also get 3 either way. Problem number 9, ln of e to the thirds. Two ways to do it. You can just cross out that, or second thing you could do is remember that the 3 can move down to the front. So that's going to be 3 ln of e, and we've seen that ln of e will be 1. Problem number 10, it says to find the inverse. Step 1 of inverse is switch the x and the y. So I got x equals log of 1/5 y. Now, step 2 is to solve for y. It's really hard to solve for y when it's in the log. Think of it as being in the log, so we have to rearrange it in exponential form. That's the base, that's the exponent, that's the answer. So the base is 1/5, that's the exponent, and then that's the answer. Now you've solved for y, so this right here is your f inverse of x. Problem number 11 asks you to graph. How we're going to graph this is I'm going to start with the original graph of log. Remember, this is just log base e. It's just log of a base of a certain number. The original log, before we shifted it, keep in mind, passes through 1, 0, and it has an asymptote at x equal to 0. Okay? The only difference is this one, because of that plus 2, is going to move it 2 to the left. Keep in mind, I'm going to move the asymptote first. So it was 1 to 0. I'm going to move 1, 2 over here. So the new asymptote is x equal to -2. And this goes here to -1, 0. But the graph still looks the same. Okay, so now if you ask me the domain, the furthest left I can go is -2. Furthest right is forever. X is greater than -2. The range, the lowest I can go is forever, and the highest I can go is forever, even though it grows slowly. So the range is all real numbers. Let's look at problem number 10. So it's asking, is this true or false? It turns out this is false, because log of 3/4 should really break up as log of 3 minus log of 4. Okay, so this is not true. Question number 13 is asking us to condense. The first thing we're going to do is take all the numbers in the front and move it to the top. Take all the numbers in the front, move it to the top. Okay, one more, move it to the top. So I have log base 3 of 32 to the 1/5 minus log base 3 of x to the second plus log base 3 of y to the half. Okay? Now, right away, I see a minus, so that's going to tell me it's going to have a division. So this is going to reduce to log base 3, and there's going to be some sort of fraction. Okay, the only thing on the bottom is the minus, so the x squared is going to be on the bottom. This is 32 to the 1/5. If I work it out, that's the 5th root of 32. It turns out 32 to the 1/5 can be broken up as 2, 2, 2, 2. So the 5th root of 32 is really 2. Okay, so what I'm saying is we can actually rewrite this as 2, if you feel comfortable. And then y to the half is really radical y, and it goes on the top because it's a plus. So that's your final answer. Problem number 14 says use change of base. So I'm just going to use change of base as log of 24 over log of 4. If you work that out on the calculator, that's approximately equal to 2.292. Let's look at question 15. There's two ways to solve this. Method 1 is to rewrite it as the same base. Okay? So the 1/4 and 8, the same base will be 2. So I can rewrite this as 2 to the -2 will give me a 1/4. Now the 8 is 2 cubed. So I can rewrite this as 2 cubed to the 3x plus 5. Okay? Now keep in mind what you do with the exponents like this is you're going to multiply it. So that's going to be 2 to the 9x plus 15. And then on this side I have 2 to the -2. Since it's the same base, it's just -2 equals 9x plus 15. You can solve for x by subtracting 15 and adding 9. And you get -17/9, which is answer letter C. I'll show you the other way to do it on the next podcast.